Send this in tomorrow.
Yeah, but I didn't just read it. You know what else?
I'll just count on down the left here. Injured, out for injury.
That way you can take it out.
Because of the malicious and savage.
It's got
Chance it.
it's full of how horrible it is and everything. It's just, what did they say?
Okay. Alright guys, so we have one more section. This last section, I think the test is 3 pages long for the final. One of those pages is completely out of this section. So this is a super important section. Okay guys?
Are there any purchase?
There's like one, with the one that like. So.
I forget which class. But you can use notes.
Yes, you guys are allowed to use notes on my final. Remember, you can use your notebook and then I'll collect your notebook and grade it afterwards. So yeah, you guys are allowed to use notes. Okay, so we are just gonna start chapter 6. I don't even know if we're gonna end up doing all of chapter 6. We'll do a fair portion, but this is the only section we're gonna do this semester. Okay, so 6.1. So chapter 6 is all about polygons. Now we've already been studying polygons, but we haven't studied like all types by any means. Okay, so we're gonna learn today how to classify polygons, and then we'll start working with like numerical problems tomorrow. Okay, so what is a polygon? So we'd have been able to get 2 more questions if we'd done this section before that. Okay. So a polygon, guys. What is a polygon? It's a many-sided figure. Okay, so what's that root word poly? Poly means many. It means more than one. Gon means a figure that's a plane figure. That's what it means, okay? So it's a many-sided figure whose sides are line segments. And that's all I'm going to say, except I'm going to put a couple bullet points on here. Each corner, what do we call corners of like triangles?
Vertex.
A vertex, right? So each corner is a vertex of the polygon. And then this is probably a new term. Any segment that you put in there, or that you can observe, if that segment connects 2 non-consecutive vertices or corners, it's called a diagonal. Okay, so that's probably a new term, an important new term, which we'll use a lot. So what's non-consecutive mean? Yeah, non-consecutive means like not next to each other, because if you connect 2 corners that are next to each other, what is that? It's a side, right? If you connect 2 things that are not next to each other, we call that a diagonal. So there's all kinds of theorems about diagonals. They have to do with really advanced stuff sometimes, but we're not going to see those for that. Okay, so just a couple notes that go with the definition. So a polygon, here's some things that it has to have to be a polygon, because not any shape is a polygon. A polygon must be connected it can't have any curves. No curved, everything has to be straight. And it also can't have any sides that cross, so that they make like more than one polygon.
So it can't have any intersections.
Yeah, no intersecting stuff. We'll see what that looks like. So let's just like throw up a bunch of things here, and we're going to name what they are. So a lot of this section, what we're going to look at today, we're going to be looking at just like the vocabulary part of the section, and then we'll do like the calculations tomorrow and Friday. I'm not going to give you guys like a review for this test. I'll talk about all the different stuff that's going to be on the test, and we'll do some of that on on Thursday. But mainly you're gonna be responsible for going back and looking yourself as you get your notes ready for the test, okay? So we just don't have time. Okay, so we'll look at that guy. Let's look at this guy. Let's look at that guy.
Does Polygon have, like, does it have a limit of how many sides it, or minimum
No.
of how many sides it has to be?
Well, yeah,
Well,
I guess it does have a
three.
minimum. You guys hear what Nick said? He just came up with the theorem. How many sides minimum does a polygon have to have? It has to have 3. How could you have less than that and be connected? 2 sides, how are you gonna connect them and not have like gaps or something? You can't, right? So 3 is the minimum number of sides. Is there a maximum number of sides you could have a polygon? You could have a 10,132nd gon with that many sides, okay? So definitely possible. Okay, so number 1, do we think that's a polygon? It is. What kind of polygon? It's kind of irregular, yes, that's a good class, that's actually a correct classification for it. We'll see what that means precisely in a second. How many? This is a pentagon.
It's got 5 sides.
It's got 5 sides. Is it like a normal? Well, I liked what Jake said. He said it a regular. Is it a regular pentagon? No way, but it's got 5 sides, so it's a pentagon. So all those things that you guys have known for quite a long time, you got to know them now. So we're gonna look at the list of the up to how many sides you have to know in a second. Okay. What about this guy? Is this a polygon?
No.
Why?
It's cross.
It's got some sides that cross or intersect. It's like 2 polygons put together, right? 2 triangles. Triangle's a polygon. So this is, as a whole, not a polygon unless you look at one piece at a time. So as a whole shape, no, not a polygon. What about number 3? Polygon?
Yes.
I don't see any curves. I don't see any crossing sides. Everything looks nice and connected. There's no gaps like that. That wouldn't be a polygon. And it's a what? Close. How many sides? 7. So this is a polygon. So how many sides? If you have 6 sides, what's that called? I think that's an
It's a
easier one,
hexagon.
like a beehive, right? So hexagon. One more is hept. These are all Greek roots. Okay, so hept means 7 in Greek. So that's what we call that. Number 4, do we think this guy, this moon type shape is a polygon?
No, it's got.
It has a curve.
It's got a curve. As soon as you get into curve land, you can't apply any properties you know about polygons. Okay? So this one's just not a polygon at all. But even if it's got just a little bit of a thing, a little bit of one side that's curvy, it's not a polygon. Okay? So circles, not polygons. Ellipses, not polygons. Okay? Alright. Okay, real fast, guys. Get out your book. And I want you guys to practice a couple more. So on page 382,
That's the homework assignment?
just in your notes. Okay. So on 382, 2 things. This should take you like 3-4 minutes. You want to do 1A through 1C, just more examples like what I did. Okay. So decide if they're polygons or not, what kind they are. And then have a look at that table. That table right there has up to 12 with a couple gons missing. If it's more than 12, we just call it like a 13 gon or a 14 gon or something. If it's less than 12, they have names that you need to know. There's names for all of them, but those are the names that we need to know, okay? So some ones that you're not familiar with in there, 9 is how many?
Nonagon.
A nonagon. What's the name? 10 is a decagon. 12 is a dodecagon. These are all ones that you need to know now. 7,
What's 11?
heptagon. 11, I don't even remember what that one's called.
Wait, how many do we need to know?
There's not.
I know a few more that aren't on the table, but
How many do we need to know?
anything that's on that table you need to know.
So 6.
What's on that table are the ones that you need to know.
And then it's N, so N, when you use that,
It's
what's,
like 13. You just gotta get the word gone in there because that means a plane. Two-dimensional shape. Two-dimensional polygon.
should we just have like, so try is 3, is that what we're doing right now? So, okay.
Just as long as you know those, we can write on this.
I have no idea.
Mr. Parks had us memorize these last year.
All of them?
Up to 10, I think, yeah.
Oh, that's good. Hey guys, 2 minutes, get that done.
This would be. Can I go grab my book real quick? Yeah.
Yeah, that's
Oh,
What was all?
It's easy. Alright, there'll be some topics for this section.
I don't.
All of them.
Oh, yeah.
so gone is plain?
Gone is like polygon.
Oh,
So when you do 3-dimensional stuff, we'll have a different name we call it. Hey guys, so I think that's enough time. 1A, what is it?
no.
Not a polygon, it's got a gap. 1B, 9, nonagon. And 1C,
No, not a polygon.
not a polygon, it's got curves. Okay, good. Alright, so let's put a couple other vocab terms up. So notice what I said about those names in that table, you gotta know them all. Okay? And I will most likely on the test emphasize ones that I think will mess you up. So the ones that you didn't know since you were a 5th grader, 9, 10, 7, those ones will probably be on there. 5th grader.
But we're allowed to have notes.
11 has a name, but I don't even remember what that one's name is. It's not one that comes up very often in nature, so we don't really worry about it too much. But yeah, you can have one.
11 are gone.
You can say that, that's fine.
11 gone.
Okay. Okay, guys. So 3 more definitions. So these are a little bit newer. This is going with what Jake said. He said an irregular type of polygon. So the word regular has a specific meaning. What's it mean exactly? It means that the polygon, it means like normal, yeah. So what's like a normal type of polygon? Well,
Put it H. So have HEP have.
okay,
There you go.
so if you're regular, then you've got to have sides that are the same, you're equilateral, and you've got to have all angles that are the same, you're equiangular. That's what regular means. So if it's not like that, you'd call it irregular. Okay. Another definition we want to know. Yeah. So a polygon is convex. You have to think about the diagonals. if all the diagonals, every diagonal, is on the inside. And we say inside as interior. Okay? We'll look at some pictures of this. Just give it a second. And then the last definition that we're going to do, I think this is the last definition for the section, is concave. A polygon is going to be concave if any diagonal, that means just one. Just like a counterexample. Everybody gets one. Okay? If any diagonal lies on the exterior. So when I think like a regular polygon, let's do like a regular hexagon over here. So if I'm doing that, then a regular hexagon is going to look something like this. Probably like the hexagon that you think about when you hear the name. That's a regular hexagon. But for me to know for sure, it's got to have those marks on it, right? So it's got to have like the equilateral marks showing that those are all the same, and angle marks showing that they're all the same. Okay, so that is a regular hexagon there. That's probably what you think of when you think of a hexagon, right? Okay, so a polygon that's convex. This guy is convex because its diagonals are all inside. You guys see that? I'm going to draw them in. How many diagonals does it have? 6. Right? Let's count them. Is that a diagonal?
No.
It's a side, right? This is a diagonal. This is one. 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 That's one. That's one. That's one. It's got lots of diagonals, right?
Yeah.
Did any of those go outside?
It's got
So it's convex. Okay, so that's a convex polygon. So how many's it got?
1, 2, 3, 4, 5, 6, 7.
Kind of hard to see, right?
I think 9.
I think 3 from this corner, 3 from this corner,
And then
3, 3, 3.
Yeah, but some would be
Yeah, and then you gotta watch out which ones overlap.
So you cut that in half technically because, or
We'll leave that till a little bit later. Okay. So a polygon is concave. Let's look at one like that. Someone who hasn't told me. What kind of polygon is this?
irregular or
It's regular, yeah.
it's a pentagon.
It's a pentagon. Okay, is it concave or convex?
it's concave because you've got diagonals on the inside, but you've also got that one because it shoots up.
So like there's a diagonal, is that inside? Yeah. There's a diagonal, that's inside. That's a diagonal. So that guy's convex, concave because one of them's outside. If any one of them or more of them are outside, it's concave. Okay? Let's do one more example. What about this? What is this? I thought it was tricky. Okay, let's name this by all the names it has. And on the test, I'll have a section where I'll say, name as many names as you can which fit the polygon or fit the figure. And you can stop at like 5 names, okay, if it has more than 5.
So it's an octagon.
So like this one, it's an octagon, yes. 8 sides.
It's irregular.
What is it?
It's irregular. Oh no, it's
Okay, let's be careful with regular, irregular. Is this regular or irregular?
Irregular.
Why are you guys are all saying irregular?
it's regular because it has all the same sides.
You're right, it is irregular.
Oh.
Why though? It's tricky. It's got all the same sides, it's equilateral, right? And it has those angles marked the same.
But the angle.
Yeah, there's a bunch of angles.
There's more angles, aren't there? There's one here, one here, one here, one here, and it doesn't have, those are definitely not the same, right? So that one was really sneaky. That's irregular, because those red ones are not the same as the other ones. So that was tricky, okay? And it's concave, because I could draw a diagonal like that or that. I think that's all we know for now. So that'd be about it. Okay. How about
Figured we would know by now.
let's name
Quadrilateral.
all the names we can put on this. It's quadrilateral.
Regular.
So if it's just got four sides, that's the name, remember. Quadrilateral is the most general four-sided figure. It's also a square. It's
Regular.
convex.
It's regular.
It's regular. Anything else? I think that this has to do with some more stuff later in chapter 6. It has other names. It's a square, but what is it also? All squares are rectangles. Aren't they? And all rectangles are parallelograms. So that has to do with stuff that we're going to learn in a bit.
But just on the test, it would stop at 5.
If you name all that stuff, though, yeah, as long as you get 5. Okay. All right. Let's do one more thing for today, guys, and I'll do one example, and then that's it. Okay, so let's do one numerical problem. Here's a big thing. This is one of the most important things you need to know from this class, coming out of this class. It's easy to forget though. So, how do you find the interior angles in a polygon? Any polygon. Inside a triangle is how many degrees? You guys all know that. 180, right? So, how many degrees are inside a quadrilateral, or a pentagon, or an octagon? Do you want to remember each one separately?
No.
Probably not. So, the sum of the angles inside and the interior, if it's a convex polygon, which most of the stuff you end up working with is convex, and it has n sides, this is a formula, one of the few that we need to remember. If you add them all up for a triangle, you get 180 degrees. If you add them all up for anything else, here's how it goes. And the triangle fits this too.
So extra sides.
You go the number of sides minus 2 times 180 degrees. So if it's a triangle, how many sides does a triangle have? 3, so if you plug that in, you get 3 minus 2 is 1 times 180 is 180. So it fits triangle, right? So if we had like a quadrilateral, like a square, how many degrees are inside a square? Well, you could put 4 minus 2 times 180. That's 2 times 180. What's 2 times 180? 360. So any quadrilateral has 360 degrees. If you want to do a pentagon, you plug in 3, it's going to have a little bit more degrees. Okay? Yeah.
It's not 720.
But that's just the sum. So if I say find the sum of the interior angles of a convex heptagon, what are we going to do? A heptagon has how many degrees inside? You go, how many sides?
7.
7. So I just go,
7
the
minus
sum is going to be
7 minus 2. times 180.
So that's 5 times 180. And then I might need my calculator. 900.
Plus 900.
So a 7-sided shape has 900 degrees if you do that. So now tomorrow we'll talk about if you know the total and it's regular, you're going to know each one, aren't you? You're just going to have to divide by how many sides. Okay, so we'll look at that. We'll look at outside angles too tomorrow. Okay. So let's see. Okay, I haven't decided when this is due. It's either going to be due on Thursday or like at the end of the class on Thursday. Like one or the other, it's going to be due before the weekend. This is a longer assignment. This is like our last normal assignment for this semester. So I'd try to get started on it. You guys have like 7-8 minutes, I think. So. We'll finish tomorrow.